welcome to our next talk. It's all about Eclipse Store. So here the title is Eclipse MicroStream, but it changed because now MicroStream is Eclipse Store, building ultra-fast Java Cloud Native persistence. No, not building. ultra-fast Java Cloud Native persistence for microservices and serverless apps with Eclipse Store. So in this session you will learn a little bit more about MicroStream, or now, as I mentioned, it's called Eclipse Store. And who of you have attended the keynote already? Okay, so some parts of the keynote are repeated here, but not all. So here we are able to dive a little bit deeper into the Eclipse Store project and talk about the functional principle. But in the end, you will learn how Eclipse Store works and how you can build the fastest database apps with Java. Please feel free to ask questions because, yeah, we are not much participants, so take the chance, ask questions. Who of you is using Hibernate or any other persistence library? Okay, yeah, good. And who of you is already working with AI or doing something with AI, machine learning? All right, okay, cool. So of course, the whole software industry or technology industry expects that now with AI, the amount of data will explode, and we will see lots of more application, lots of more innovations, and all of these applications, these new applications, there are three critical factors for all of these apps, and this is high performance in the future, lowest data storage costs, and simple implementation. So it's because the faster your system is, the more effective it will be, and of course the simpler you can implement new innovative applications, the more applications can be built, and companies will need more and more innovative applications using AI, machine learning. And so this is really a big topic, and companies they have challenges with cloud costs. So the cloud costs are skyrocketing, and so this is really an issue for most of the software companies in the market. So we are super happy to announce that now MicroStream is now Eclipse Store. And we split the project into two Eclipse projects. So one Eclipse project is Eclipse Serializer, and it bases on the MicroStream Serializer. MicroStream Serializer is the core of the MicroStream persistence framework. And we built a new serializer because the Java serializer is limited in terms of complexity of the data structure, and it's highly insecure. So this was the reason why we developed a new serialization framework that is able to deal with complex object structure. This is the base for Eclipse Store, which is a persistence framework, and this talk is all about the persistence framework. And now both frameworks are available on GitHub. So it's not the final release, it's the first milestone release, but there won't be much challenges, sorry, not much changes until the final release will be available. So expectedly in some weeks we will see the final release, but you can use it already. It was released yesterday. It's now available on Maven Central. And the Eclipse Store also should now become a standard, similar to the JPA standard, which is built for object relational mapping frameworks like Hibernate. It defines a standard, and now the functional principle of Eclipse Store will also become a standard. Hopefully we are able to start this year, at the end of the year, by founding a new working group within the Eclipse Foundation. Some information about myself. So my name is Markus Kett. I'm CEO and co-founder of MicroStream, the company behind the Eclipse Store project. And I started with Java almost 20 years or more than 20 years ago. So we started with a web design software called XPage Internet Studio. Then we built a Java development environment. So this was in 2006. And the goal was to build a visual development environment for Java. Today we would say it's low code. And the goal was to build something like Visual Basic, but for Java. So developing applications very easily. And we were quite successful because we had a beautiful GUI builder. The problem was database programming in Java is much more complicated in comparison to 4GL tools like FileMaker or Oracle Forms, Fox Pro and something like that. So there were a lot of people who wanted to migrate to Java these days, but it was too complicated for them. And so this was also our challenge, because now we wanted to simplify database programming in Java. This was the reason why we migrated the IDE to Eclipse, to the Eclipse IDE. And we developed RapidClipse, which is a Eclipse-based development environment. And we worked for many years on improving the JBoss Hibernate tools for Eclipse. So we tried to simplify using the JBoss Hibernate tools, to make it more simple to create the object, the data model, to import and export the model. Then also we wanted to try to improve the query language, and we saw that JPQL was not type safe, so we saw a lot of SQL strings. Then we recognized, okay, there is a type safe query language. It's called JPA Criteria API, which is now type safe, but the problem here was it was too complicated to read, and much overhead, and not really nice to read. So this was the reason why we then built a new query language called JPA SQL. It's a kind of like a DSL, so you can write your SQL syntax, and it generates under the hood, it generates JPA Criteria API code. Crazy. Just for simplifying database programming with Java based on Hibernate. Then in 2019 we founded MicroStream and started with MicroStream, and yeah, now it's Eclipse Store. So this is a little bit about my background, my history. So I also grew up with Commodore 64 and some assembler programming before I switched over to Java. So this is here. RapidClipse is also free and open source. You can download it, check it out. Then we recognized, or we thought about, can we improve database programming? So is there any way to make it more simple? And because everything that is built with Java is actually simple. So when we execute something in Java, this through runtime, this is not a problem for developers. So we have no issues. Everything is really fast. We have no limitations. But as soon as we want to store data, then it suddenly becomes really complex. Some facts about Java. We all know, of course, Java is a great programming language. It's object-oriented, type-safe. We have a super powerful ecosystem, lots of APIs and frameworks we can use, and it's stable, and you can run Java programs you have written 20 years ago, so great. And it's fast, so because of the JIT compiler, so JIT compiler accelerates your Java app, and it's almost as fast as a C program. So performance is not our issue. And in Java we have also a great data structure. We have the Java object model, and we can deal with all data structure and with all data types, no matter whether we use JSON or XML, or we store a simple list in memory, or we deal with a complex object structure with a complex graph. Everything is possible in Java, no problem. So it is kind of like multi-model data structure we have in Java already. Searching and filtering, not an issue in Java. So because we have Java Streams API, with Java Streams is very effective. So even if you have terabyte data in memory, and you have really complex data structure in memory, with Java Streams API you can search it in microsecond, and we have a microsecond response time. This is awesome. When we talk about the performance of a database, we talk about milliseconds, which is factor 1000x slower than Java in memory. So great news. And now with persistence, there's also good news, because the cloud vendors, they provide now binary data stores, and they are 99% cheaper than any database in the cloud. For example, if we need 250 gigabyte PostgreSQL as a service, and we choose a small machine, then it costs around $8,800 per year at AWS. So I guess the prices at the other cloud vendors are similar. If you need more replicas, so if you want to distribute your database, or you want high availability, then you need more nodes, then the price will double or triple. So for instance, for 6 nodes, you will pay around $50,000 annually for 250 gigabyte database. We do not talk about license fees, so it's only for the infrastructure. If you need 250 gigabyte cloud object store like AWS S3, then you only pay $70 annually. So you can save 98% database costs every single year. That's great. And all cloud vendors provide similar cloud binary data storages. They call it object or blob storages. And with Eclipse Store, now we combine the power of the JVM and the power of the programming language Java with the cloud native object storages. And we didn't invent this concept. This concept is already existing since Java is existing. It's called system prevalence, and the functional principle is really simple. So it says it's a simple architectural pattern. So just keep your data in memory and use your programming language, use the native model of your language, and execute everything in memory. So this will be very fast. And if you need persistence, just create a snapshot of your system state. That's it. And then you can, when you shut down your application, when you start your machine again, then just load the snapshot, restore your system state, and everything will be in memory. And this is great. So simple architecture, core Java only. Great. There are some challenges with this functional principle, because you don't want to have the entire database in the memory. It could be a little bit expensive, probably. And we don't want to create a snapshot of the entire system state. So which means you should have to store the entire database all the time. So this is not really cool. For small applications, okay, but for big applications, this might be not a good solution. Then we saw that many banking companies build similar systems. So everything is in memory because they need low latency, high frequency trading apps. And also the game vendors. We saw that a lot of game vendors build similar systems, but they build individual systems. So which means if you want to solve these problems, then you have to care for your own. And with Eclipse Store, we have solved these challenges with system prevalence, built a framework that now you can use it, and you can use it easily for your own business applications. So Eclipse Store, in a nutshell, is a Java native micropersistence layer, similar to Hibernate, because it's a persistence layer for storing objects. But on the other hand, it's completely different to Hibernate, because Hibernate is for storing objects in a relational database. With Eclipse Store, you store your objects in any binary data store. So you can choose your storage.
Can be used with MongoDB?
So the question was, can it be used with MongoDB? We have a connector to MongoDB. Here we have still some issues with consistency, but there is a connector, and we have connectors to many other databases. So you can check out the list and choose your database. And it's because all the classic databases are also able to store binaries, of course. We recommend to use the cloud object storages because they are fully managed. And so the cloud provider, they cares for everything. So they care for availability, they care for backups, they care for data center replication. So everything is provided, and you just pay some $70 for 250 gigabyte. But you also can store your data in plain files, for instance, and write your data on persistent volumes, for instance. So, and Eclipse Store is able to deal with all objects and with any structure of your objects. So there are no rules how you should build your data model. There are no rules in terms of user-specific format. So just build whatever you like, whatever is possible in Java, and Eclipse Store will be able to store it. And you can store, of course, the entire system state, but in most cases, you will just store the deltas. Just the changes are serialized to disk. This is the functional principle. and this is transaction safe. And vice versa, the framework allows you to load either the entire system state into the memory, so you can do that, but in most cases users just load individual subgraphs in the memory, so only the data you really need can be loaded into the memory, which means you can run it with huge memory size or also with just 1 GB memory, or even with serverless functions where you have only 512 MB or something like that. This is also possible with Eclipse Store. So you can use lazy loading for loading object references into the memory, and the loaded object references are merged into your object graph automatically. So you don't have to deal with object copies. Everything happens on your object graph in memory. There are 3 benefits. So the 3 major benefits, of course, are high speed, because now you're able to use Java for in-memory data processing, because Java is fast. Java provides you everything for that. The only missing piece of puzzle is persistence. There is no feature, no function in Java for storing data persistently on disk. Now you get it with MicroStream or Eclipse Store. Lowest data storage costs, as I mentioned. You don't need a database as a service anymore. You don't need a database at all. You can use blob stores. They are super cheap, or just plain files. They are not managed, but it's possible. Then they are much faster, because the trade-offs with object stores, they are not that super fast. So with using plain files, you will be a lot faster, of course, and it depends on the use case what you should choose. Eclipse Store runs within in your JVM process, similar to Hibernate. It's a tiny open source library. It's available on Maven Central, and of course the code is on GitHub. And if you like the concept, if you like Eclipse Store, please store us on GitHub. So it's super important for us, and motivation for the developers. Eclipse Store is also well integrated into Project Helidon. And who of you uses Helidon in your project? No one so far. So if you want to build microservices, you can use Helidon for writing your microservices in Java. It's a very popular framework for that purpose. And MicroStream, or now Eclipse Store, is also well integrated with Micronaut, which is also very popular framework for creating microservices with Java. And we provide also integrations for other frameworks like Quarkus or Spring Boot, and CDI integration. So the framework is already well integrated with other solutions in the Java ecosystem. So how does it work? Let's have a look inside the database. Here we can see on the right side we have the architecture of a database server. So we have some business logic, stored procedures, stored functions. We have some memory, of course. Mostly we will have a lot of memory in our database server. We have a database management system, of course, and storage. On the right side we have Java application or a microservice. We have some objects in memory. We need normally we need Hibernate for object relational mapping, or a data conversion for our NoSQL database like JSON. And if you use Hibernate, mostly we will use a local cache and a JVM, of course. And now with Eclipse Store, as I mentioned, your object graph is a kind like in-memory database. So the data are already in memory, which means you don't need a cache anymore. And we replace Hibernate or any other mapping with Eclipse Store. We can skip the local cache, and so the complexity is reduced, and on the database side, so as I mentioned, we have data already in memory, which means we don't need memory on a database side. We have our business logic, of course, is written in Java, which means we don't need stored procedures, stored functions. We have in Java concepts for concurrency management, and everything else we care for validation and something like that, locking. So we don't need the database management system anymore. We can do it in Java. The only thing we have to keep or we need is just storage. And so we get out a very simple architecture, easy to use, core Java functions only, core Java features only. So, and now, is it really fast? We have a small performance demo. It also runs on our website. This is an example, so don't trust. It's by us, it's built by us. You can check it out. It's the code is on also on GitHub. You can check it out. You can implement, can create test data. Here we are running two applications in parallel. One is built with a traditional Hibernate stack. We use a PostgreSQL database, 250 gigabyte data. We use Hibernate. We use cache, and this application is already running, which means it's a hot cache. So we read data directly from cache. The second application is built just with core Java and MicroStream. So it has to be updated, of course, in the future for Eclipse Store. And here we can see we use Just Streams API for searching and filtering. And all queries are almost 10 times, sometimes 100 times faster, but sometimes more than 1000x faster than a comparable JPA query. And you can use it with all Java applications. So you can check this out. You can try to implement your own queries. You should do that. But in most cases, you will see Java is always faster. And actually, this is not really true. So this is not MicroStream performance or Eclipse Stream performance. It's the performance of the JVM. This is the performance of Java. We just add persistence. That's it. Great numbers. Hey, come on, you are so bored. Who needs performance?
I'm just wondering about
Yeah.
I think it's related with the database on the backend, because I'm using MongoDB like database in my project, and I'm using the Spring data, and I'm happy with the performance from Spring data.
Yeah. Of course, hey, it's Java. We have great features. We have great databases. You can build applications and you will be satisfied with the performance. No question. But in some cases, developers are not satisfied with the performance. And sometimes we see that there are also additional cluster running, so like Elasticsearch, and probably you run Elasticsearch because you're not satisfied with your database performance. And it's not needed for all use cases. So probably you have high frequency applications. You need lots of transactions in memory. Then it will be a lot faster than a comparable database, because here we can see this is the fastest case, because here we read data directly from a cache. We don't hit the database. And to be fair, we have to compare Java streams, which is executed in memory, with access to a cache like cache. Otherwise, we would hit the database and it would be even slower. Because if we hit the database and the database has to fetch data from a hard disk, it will be even slower. With JPA, this is the fastest case. Who has performance issues? No one. Sometimes. Okay. What is the question?
Yeah, I had a question concerning transactions you mentioned.
Yeah.
As properties. So maybe you can give an example how transactions would look like.
Yeah, we will have. I will show you then some slides later. Yeah, there was a question. Yeah, let's see. Yeah, yeah. So it seems you have some doubts. You're not convinced already. What I show here is really the performance of Java. There's no magic behind the scenes. We now compare just core Java Streams API with reading data from an EH cache. So we also can use object graph distribution, so we can replicate the state of your JVM through even hundreds or thousands JVMs with MicroStream cluster, and we can build distributed applications. So here is a classic architecture. So we have multiple instances of an app or a microservice, so multiple application nodes. We have a database cluster, and in between we have a distributed cache. Because if we can use, of course, local cache like EH cache, but as soon as we build distributed applications, mostly the cache will run between the application and the database. Who has such an architecture? Okay. So this is common enterprise architecture. 3 clusters are running. So with MicroStream, as I mentioned, we replace Hibernate. We replace local cache. So we replace the Hibernate nodes. We use, let's say, we use S3. It's high available already, so we don't need more nodes. We just use 250 gigabyte of S3, which means we don't need a database cluster anymore. We can skip the machines. And because of the object graph is replicated through multiple JVM processes, we keep the data in memory. It's already working like a distributed cache, which means we don't need a distributed cache anymore. We can skip the distributed cache cluster as well. So we can skip 2 clusters. And this is the final result. Only 1 cluster, we use replication, and we need a binary data storage. That's it. Saving lots of machines, lots of resources, and everything's core Java. We can also use this cluster concept for serverless functions, so stateless functions, for instance, or stateless apps or microservices running in Kubernetes pods, which are stateless. Can also use different programming languages and just query the cluster by using REST, for instance. As I mentioned, we have connectors to all major cloud providers and their object stores and other database systems. It runs wherever Java runs. The only requirement is Java version 8. You can use it with all JVM languages and so on. MicroStream is not, or Eclipse Store is not just a serializer. Serialization is the core of the framework. We have the persistence framework for the JVM and for Android. Then you get additional functions like the type mapping, garbage collection, file system abstraction, and so on. A REST interface, a browser, kind of like browser for storing, for browsing your storage data, and so on. And some converter for CSV and so on that you can import and export data. This is not a closed system. All right. Altogether, this is Eclipse Store. How does it now work in detail, in more detail? As I mentioned, you can build your object model completely freely. So there are no interfaces to implement. There are no annotations. Just use all Java types. The only thing you need is an Eclipse Store instance. So we need an Eclipse Store instance, and then you can add your objects. We need a storage target, and then we can create new objects and add the objects to the root object here. So, and this is the entry point. We have a root object, and now we can add some objects, and then we just have to call one store method to create a snapshot of the changes on the object graph. So then we create a new binary file, and it's stored appended to the file storage. So each store will be stored appended, and this store function is transaction safe. So this will be executed as a transaction. This is a atomic all or nothing operation. So we can add some more objects to our object graph, call a store method, then the serializer will write a new binary and store it appended to the file storage. This is how the functional principle works. So we create more and more binaries, and you don't have to care for the complexity on our object graph. You can use inheritance, whatever you like. So if you change some objects in the object graph, just change objects, do whatever you like, and then you just have to call the store method again. But we do not override data, existing data in a file storage. We also add the changed objects to the file storage. So if you start your application, then MicroStream or Eclipse Store will load the entire object graph structure into your memory. But only the structure, only the object IDs are loaded into the memory. No data are loaded. So your developer, you decide which object references should be loaded into the memory or not by using lazy loading. So if you build a microservice, fast startup time is important. Just use lazy loading, no data will be loaded. If you build a monolithic application, you start it once, runs for 2 years, yeah, you can load the entire system state. It depends on the use case. So then we load data lazy, only subgraphs are loaded, and data are merged into your object graph, and your object graph gets updated. This is how it works. There we have just a wrapper class for lazy loading. There are no annotations needed, so very easy to use. Just POJOs and so on. No, you do, it's not mandatory, because we do not use the Java serialization. With Java serialization, you have to implement the interface serializable. With the Eclipse serializer, you don't have to implement serializable anymore. So this is very convenient, and you also the complexity is not limited. So the depth of your object graph is not limited. As I mentioned, you can build super complex object graph, and it can be serialized. And you also can change your objects, your classes, because you will have to change your classes all the time. And schema changes are super easy with MicroStream or Eclipse Store, because we have this legacy type mapping. You have an example of queries, Streams API. If you change class, then and you start the application and you load the object reference, then MicroStream will compare the objects with your class. If there are changes, then MicroStream can solve it automatically. There is a heuristic. If you add some fields to your class, or you rename fields, you delete fields. This can be solved by the framework automatically. For more complex cases, you can define a legacy type mapping. And then you just store the object again to the file storage. And then MicroStream or Eclipse Store will add a new file, a new binary to the file storage. Then we have two versions of our object in the file storage. The new version and the old version. And now you can define if you want to, whether you want to keep the old object or let the garbage collector of MicroStream or Eclipse Store remove the old object from the storage. So we have this garbage collection and it works on file base. So here it is how it looks like. So we have lots of older versions of our objects in the file storage, and then we can define that the garbage collector should remove all the legacy objects from the file storage. So this is the functional principle. You don't have to care for memory management. So everything is done by the JVM. So you should build an object model that is really suited and for your RAM size, of course, but you don't have to care for memory management. So everything is provided by the JVM, and with modern JVMs like OpenJ 9 or Azul, you can also run terabytes of memory without any garbage collector issues. So you can, if you run big memory machines, you should check out Azul. So it really works great. The great thing is the latest Java versions are much faster than the older Java versions. So if you build a Eclipse Store application and then you update your Java version, your application gets faster automatically because your JVM is faster. That's really great. And with virtual threads coming up, this will again accelerate our application. So this is great combination with Eclipse Store. With Eclipse Store, there are also some rules and there are some challenges, of course. And it's a paradigm shift in database programming. So you have to rethink database programming. It's because on the left side we can see this is the traditional database server paradigm. We have a database server. Everything is executed on a database server. And with MicroStream or Eclipse Store, everything is located, all data are located in a memory. It's in memory. You search in memory. This is the big difference. You don't have to query a different machine. And this is the reason why searching is faster, and this is the reason why it's even faster than the in-memory database. So popular question, is this faster than SAP HANA because it's in-memory database? Is it faster than Oracle in-memory database? Yeah, it's faster. Why? Why can this be faster? It's because an Oracle database never gives you Java objects, right? That is the reason why we can read data directly from a local cache, and it's slower than Streams API. Why? Because the cache doesn't give you Java objects. It has to be serialized and deserialized when you read, when you write data or read data from a local Hibernate cache. And this is the reason why it can take also milliseconds when you read data directly from a local cache. And with Java cores, Java will be faster. Mostly, in most cases. Do I have to load the entire database in a memory? No. You can do that if you have enough memory, because we save a lot of machine resources in memory, and you can put more memory in your application nodes. That's great, then it will be faster. But if you don't have enough memory, it's not a problem. You have lazy loading. You can also have a huge data storage, but only some gigabyte memory. What are the use cases? Of course, low latency applications. If you build a boring office application, which is not a bad thing, but for only some people using it, you won't have performance issues, of course. If you're not satisfied with Hibernate and caching, check it out. Probably can help you. It's not, the benefit is it's not more complicated for you to learn. It's easier because it is already core Java. So there are no new things to learn. So low latency applications, high frequency trading apps, gaming apps, caching, microservice storage or serverless storage, because the rule actually is a microservice that stores data should have its own database. This can be challenging. And because of each microservice has a specific use case, probably the data structure will look like different. So if you have a microservice consuming sensor data, probably you will store it in a time series database. But if you have a microservice that consumes very complex data, probably a graph database would be better. So you need for microservice infrastructure multiple databases. This can be also challenging and expensive. With Eclipse Store, just need Eclipse Store, because Java is dealing with all data structure and Eclipse Store stores it persistently on disk. Much easier. Mobile and edge apps. So if you build Android apps, no one? Okay. But it runs on Android as well. We have the same framework. And of course for AI machine learning. This is great for AI machine learning because mostly they use monolithic applications, run their models in a big memory machine, but you need fast persistence. So this is great combination with Eclipse Store. Or when you have bigger, much bigger machine learning algorithm that can't run in a single machine, then you can use the Eclipse Store cluster for distributing your machine learning application. It's super cheap storage and easy to use. Challenges are, there are challenges, of course. It's built for Java developers, so we never thought about this should run for Python or for any other programming languages. This is built for Java, and it's built for Java developers, not built for DBAs, because there is no relational model anymore. You cannot query your storage with SQL. There's no SQL support. You have to, if you want to let third-party applications get access to your application, to your data, to your database, you have to create interfaces for that. You cannot let a third-party application get access directly to the database. So these are the trade-offs. It's not it's a storage engine. It's not a database management system. Yeah. Then we have some challenges, of course, with the Eclipse Store cluster, but with we provide a fully managed service for that, so you can use it on premise. Then you have to deal with Kubernetes, of course, or something more simple like AWS EKS. Then you can use it, of course, but DevOps know-how is mandatory. And if you use Eclipse Store cluster as a service, then it's super simple because it's just a simple jar deployment. You can configure how to scale out, to scale in, create plans only with mouse clicks. So this is what Eclipse Store is, and conclusion, it's built for high performance. It provides you or enables you to save lots of database costs in the cloud. You don't need a database service anymore, so you can save more than 90% database costs in the cloud, and it's simple to implement. We have some more talks about Eclipse Store at the conference. also performance benchmarks. Talk about the performance benchmark. So check this out. It's open source. It's free. You can use it in production already because the framework, the project was started almost 10 years ago. It's used by big enterprises like Allianz, insurance company, Fraport, biggest German airport company. More and more companies use it. Yeah, check it out. Try to beat the JVM performance. And feel free to ask some further questions. Yes, please.
So did I get it correctly that there is no like management UI or something like somebody can look into the data? So if you wanted something like this, you need to program it yourself.
There is a REST interface that gives you access to the storage data, and there is a graphical user interface, and you can browse through the storage data. But it's not for changing the data, of course. Yeah, it's just for as a viewer.
But if somebody wants to generate a report, some portion of data or something like this, would it be possible with this?
Yeah, absolutely. It's because your data are in memory with Java. Build it with Java. You can use every framework that is available in the Java ecosystem. You can combine it with Lucene, build your index. You can create reports with Jasper reports. You can use everything because it's pure Java, and there is no specific requirement for using Eclipse Store. Imagine you build a Java program and you don't care for storage, which means you can use everything that's possible with Java. Yeah, there are.
Yeah, one question.
Okay.
If you have some millions of orders in your object graph,
Yeah.
and do you have some lazy loading mechanism to load partial orders and to filter them on the fly?
Yes, the question is about lazy loading. Yes, of course. So we can use lazy loading to load individual subgraphs in the memory. We have lazy collections you can use, and of course you should build an object model that's really suited. You can use sharding, for instance. It depends on how you build the object model. So we ran out of time. I'm sorry for that. One last question, please. And yeah, you can use it. Yes. And by the way, our next speaker is Florian, who talks about MicroStream in more technical depth and will show some code and how to code with MicroStream. If you have any questions, you can visit our booth, of course. There are the people who write the code, and you get a beautiful T-shirt. I hope you like the MicroStream project and the Eclipse Store project, and have a great day at JCon. Thank you so much for joining.